6.2, properties of rational exponents. First we have, if I have two bases that are the same, and I'm multiplying them, I'm multiplying like bases, what do I do with their exponents? Add them. You add them, and so that's the same for fractions as it is for integers. Now, the only difference here is I need to find a common denominator. So I have 7 to the 1/4 plus 2/4 gives me 7 to the 3/4. Do you have to show me that if you know intuitively that 1/4 plus 1/2 is 3/4? You can skip that step if it's an easy one, but I want you to write it down in your notes so that you have that concept and that idea. That's what you need to do. Okay. If I have...
Wait.
Yep.
Why don't you... What do you mean, oh boy? Okay. Why don't you have 49 and 3/4? Because isn't it 7 times 7?
Okay. This is 7 to the 1/4, 7 to the half. So no, you don't multiply 7 times 7 and then add their exponents, because what the exponents are doing, it's like they're counting factors. So, and that's intuitive when you're dealing with integers, because if you had 7 squared times 7 to the first, well, that's 7 to the third, right? So that's 7 times 7 times 7. Okay? When it's integers, it's intuitive, it kind of makes sense. So what I want you to do is apply what you know from here up here. So yes, no, you do not multiply the 7 times 7, you just add the exponents. That takes care of that. So that's a good question because you're not the only one to have it. Okay? The comments on the side are not helpful, guys. Okay? I have 4 to the 1/3 squared. If I have a power to a power, what do I do? Multiply the exponents. So that's, again, the same thing as we did with integers, only when I multiply fractions, if it's an integer, I put it over 1 and I multiply across the top. So 1 times 2 is 3. 3 times 1 is 1 times 2 is not 3. It's 2. 3 times 1 is 3, and so I have 4 to the 2/3 power. Okay? So you have to remember how to multiply your fractions in order to do that part, which you got a little practice with that yesterday. Okay. Now, I want to look at this. I do not have like bases, but they do have the same exponent. If they have the same exponent, you can combine them. So I can write this as, I'm going to do 2 sets of parentheses. I'm going to do 4 times 3 times, not point, 4 times 3, all raised to the 5th power. If they're both raised to the 5th, I can put them together. And then that's raised to the 1/5 on the outside. I'm doing the inside first. 4 times 3 is 12. So I have 12 to the 5th raised to the 1/5. Now I have a power to a power, so I can multiply. So 12, well, 5 times 1/5 is 1.
Negative 1/5, so it'd be negative 1/5.
Negative, oh, I missed one. Good, I'm on a roll today. So if it's negative 1/5, then it's 12 to the negative 1. So that's going to be 1 over. Okay, questions on that one? There's a lot of different things going on in that one. Okay? Now, if I have like bases and I divide, what do I do with their exponents? Subtract. So if I have 5 divided by 5 to the 1/3, then that's 5 to the 1 minus 1/3. have to, again, get a common denominator. So that's 5 to the 3/3 minus 1/3, or 5 to the 2/3.
3/3 is 1.
Yes, it is. That's when I got the common denominator. I replaced it with 3/3, so then when I subtract, I get.
Well, you could do 1 minus 1.
You could do that one in your head, and that's fine, but I'm putting it in the examples so that when you get one that's not quite so intuitive, you see the pattern, okay? So yes, on your assignment, if you went from here to here, I would be okay with that. Okay, questions on any of those? Like I said, nothing new, we just happened to put fractions in there instead of just integers.
While we're doing that,
No, well, we're not done yet. Okay, so let's look at this one. If I have 20 to the 1/2 divided by 5 to the 1/2, again, the first thing I would look for is to see that they have the same exponent inside the parentheses. So I have 20 over 5, that in parentheses, to the 1/2 power. Now, the reason I did it that way is because I looked at that and said I can simplify that. So it's 20 divided by 5 will simplify. If it's not going to simplify, maybe you don't need to do that. So that means 20 divided by 5 is 4 to the 1/2.
2.
Still to the 3rd. Well, what is 4 to the 1/2?
2.
2, because the square root of 4 is 2. So that's 2 to the 3rd power. 8. Okay, so anytime you have something that has a square root or a cube root or a fourth root, you need to go ahead and simplify it on down. If it's like 5 to the 1/3, then you can leave it as 5 to the 1/3, or the cube root of 5. Okay. Now, when you have something that looks like this, the cube root of 12 times the cube root of 18, now it's true that this is the cube root of 12 times 18. And you can multiply that out and then try to find a cube root. But if you're doing this without a calculator, sometimes it can be helpful to not multiply it out right away. 12 is 4 times 3. 18
6 times 3.
is 6 times 3. Continuing my factoring tree, this is 2 times 2 times 3. So if you look at this, another way I could write this would be, okay, if I look at all the 2's, I have 1, 2, 3 2's, 2 to the 3rd,
And 3 3's.
and 3 3's, 3 to the 3rd. Well, if I take the cube root of 2 to the 3rd power, I get 2. If I take the cube root of 3 to the 3rd power, I get 3. So I get 2 times 3, which is 6. If you multiply 12 times 18 and take the cube root, you get the same thing. This is a little less.
12 times 18 divided by 3, that's 6.
No, you don't divide by 3. You take its cube root.
So 12 divided by, or 12 times 18, and whatever that equals, whatever 3.
The cube root of 12 times 18 should be 6. Yes. Unless I mucked up my arithmetic again.
I don't think you did.
Okay? So yes, that's another way to do it. And if you, like I said, if you do it without a calculator, it makes life a little bit easier. Okay, so let's look at this one. Fourth root divided by a fourth root. Again, I see that I can simplify these. So I can put them together. The fourth root of 80 over 5. What is 80 divided by 5?
Be like 22.
16. What is the fourth root of 16?
2.
Okay. So again, recognize any simplifying you can do right off the bat. It's going to make your life easier every time you can simplify something. Let's see if you can help me with this one. Now, again, they both have the raised to the 1/4 power, so we're looking at a 1/4 root to the 1/4. I have 3 times. What am I going to put there instead of just multiplying 3 times 27?
you're gonna do 3.
3 to the
Three.
third power. Well, cube, that's right. That's
Use
right.
our calculators for these, or
You aren't going to have them on the test. So, yes, you can use them right now for practicing, but you need to be working toward not needing that. So then this is 3 to the 4th raised to the 1/4, which is just 3. So again, if you multiply it out, you can still get the right answer. This gets it a little quicker and easier. Oh, let's see. Okay, if I have the cube root of 54, first thing, if it doesn't come to mind that I have something right away, let's simplify that. If I have 9 times
6.
6,
3 times 3.
3 times 3, 3 times 2. Well, I'm taking a cube root. Guess what? I have 3 3's. So this is the cube root of 3 to the 3rd power times 2. Well, 3 to the 3rd, if I take its cube root,
27.
it's the cube root of 3 to the 3rd?
That must be 1.
3.
Oh god. Wrong again.
Okay, the 2 stays under the cube root. Okay, so you could break that down just the same way you did for square roots. Okay, so find any perfect cubes, and the easiest way to do that, put it into prime factored form first. Yeah, number 10. Square root of 56 over the square root of 2. Now what do I got to do first? Put them together, because they're both under the square root. What's 56 divided by 2?
20.
What perfect square goes into 28?
4.
So this is the square root of 4 times 7, but the square root of 4 is 2.
2 and 7.
So it's 2 root 7. You didn't think that was easy when you first did those. You're making progress. Okay. Once again, we're going to look at that 4th root of 144 before we start. Well, let's see. The first thing that comes to mind is it's 12 times 12.
Which is 4 times 3 and 4 times 3, which is 2.
Okay, 4 is 2 times 2.
That's a lot of numbers.
It is a lot of numbers. So now, just so we keep track, I've got
4 2s.
4 2's
3 3s.
and 2 3's. So the first thing we're going to do is we're going to rewrite this in prime factored form. So I've got 3 over the 4th root of 2 to the 4th times 3 squared. Well, the 4th root of 2 to the 4th is 2. So I've got 3 over 2 4th root of 3 squared. So now, in order to make it, I'm going to do a little thing on the side here. If I do the 4th root of 3 squared, that's the same as 3 squared raised to the 1/4 power. So what's the exponent of 3? 2 times 1/4? 1/2. So this is 3 to the 1/2. Well, so if the 4th root of 3 squared is the square root of 3. Now, top and bottom, what do I do to simplify this one? You guys know this?
I think there's a square root of 3 on both sides. So
On top and bottom. So square root of 3 on the top, square root of 3 on the bottom.
3 root 3 over 2.
3 root 3 over 2 times 3. But the 3's will simplify, so I just get root 3 over 2.
How did you get 2 root 3? On the side you got.
Okay, right here. Okay, from here I had the fourth root of this.
Yeah, I know that.
So that was 2.
Yeah.
So then it was the fourth root of 3 squared.
3 squared is 9.
3 squared is 9. But I wanted to simplify this. So I took 3 squared to the 1/4 power, which is 2 times 4 is 1/2, so that's 3 to the 1/2. 3 to the 1/2 is the square root of 3. Okay. So that's where the square root of 3 came from. It came from right there. Okay. Okay, you can put away your notes.
Time to do the worksheet.